Hello and welcome to this video for Scholarship Calculus, question 1b. Alright, so we're just going to be continuing on from question 1a. So if you want a brief detail on what this series is going to be about, please go back and watch that video since I give a brief little introduction at the start. But for now, we'll just get straight into this question. Solve the following system of equations for real x and y. X plus y equals to pi on 4 and tan x plus tan y equals to 1. Alright, so let's just write down our equations first. Again, so we have x plus y equals to pi on 4. And we have tan x plus tan y equals 1. So let's start off by looking at the easier equation. So I think the easier equation is x plus y equals to pi on 4. So we can rewrite one of these variables in terms of the other and substitute it into a second formula. I think that's the best way of approach. So we can say that x equals to y minus pi on 4. Or other way around, pi on 4 minus y. And let's substitute it into equation 2. So we have tan of pi on 4 minus y plus tan y equals 1. And in terms of what to do after this step is, I think, in terms of overall strategy, I feel like since you're looking at a tan of something minus something else, we can be looking at some of the tan formulas to see whether or not you can rewrite this as only tans of a single variable. So in this case, we're looking at the equation that tan of x plus or minus y equals to tan x plus or minus y over 1 minus plus of x tan x times tan y. So we're going to be using this formula in order to simplify our equation. So tan pi on 4 minus y, that is the same as, this is equal to tan of pi on 4 times, not times, but rather, in this case, we have pi on 4 minus y, so we're going to be putting a minus here. So minus of tan y all over 1 plus of tan pi on 4 times of tan y. Plus of tan y equals to 1. Tan pi on 4 is 1, so this will simplify down to a pretty nice formula. So we have 1 minus tan y over 1 plus tan y. And that is equal to 1 minus tan y. So a lot of people tend to just be like, oh, look at this. We have 1 minus tan y on the left, and we have 1 minus tan y on the right. So let's just get rid of it. But the problem is, in this case, with solving this equation, if you do that, you're actually eliminating possible solutions for this equation. So it's best to just like keep it like this for now, and then we solve for tan y at the end. Okay, so let's just not fall into the trap by just cancelling out possible solutions. By removing the 1 minus tan y, you're actually just killing off possible solutions to the equation. Okay, so let's move 1 plus tan y to the other side. So we have 1 minus tan y equals to 1 plus tan y times 1 minus tan y. So we get 1 minus tan squared of y. And the 1 and 1 cancel each other out, which is pretty nice. And we have tan squared of y minus tan y equals to 0. So therefore tan y multiplied by tan y minus 1 equals to 0. So we know that tan y is equal to 0, or tan y equals to 1. So in this case, we're going to be using the general solutions formula in terms of the, in terms for the tan. So we have tan of y equals to tan of alpha. Then therefore, we know that y equals to n pi plus alpha. Okay. So in this case, if we look at tan y equals to 0, so we can rewrite 0 as tan of 0. So we can say tan y equals to tan 0. So therefore, alpha is equal to 0. So therefore, in this case, y equals to n times pi. Let's look at the case when tan y equals to 1. So we can substitute 1 as tan pi over 4. So tan y equals to tan pi over 4. So the general solution in this case would be y equals to n pi plus pi over 4. And we can just use equation number 1 to find the x's for each of these corresponding cases. So if y equals to n pi, then x equals to pi on 4 minus n pi. And if y equals to n pi plus pi over 4, then we know x equals to pi on 4 minus n pi plus pi over 4. So x equals to, what is that? Pi on 4 minus pi on 4, so that's just negative n pi. And this and this. Okay, so in this case, we have a y equals to n pi, or x equals to pi on 4 minus n pi. And we also have y equals to n pi plus pi on 4, and x equals to negative n pi. However, notice that x and y are actually symmetrical in this equation. So like x plus y equals to pi on 4 and 10, x plus 10y equals to 1. So in this case, you can actually switch around these solutions. So you can say that x equals to n pi and y equals to pi on 4 minus n pi. And you can also switch around the other solution. So you can also say that y equals to pi on 4 minus n pi, x equals to n pi. And you can also say that y equals to negative n pi and x equals to n pi plus pi on 4. However, those are the general solutions for this equation. Pretty tough one in my opinion, since you have to notice using the tan formula, and then at the end, I would suspect that lots of people just wrote down y equals to, or just solving these equations for one case of y. So like saying that just, we can just say that y equals to 0 or y equals to pi on 4. However, you're leaving out an infinite possible solution since tan is repeating. So we have an infinite number of solutions to this equation depending on the value of n. So in this case, we're going to have to use the general formula in order to find all the solutions of y and x rather than just one. Well, I do suspect you will get partial marks if you do find just one possible case for x and y. However, definitely in terms of this equation has an infinite number of solutions. So being able to notice that this equation has infinite number of solutions and finding those solutions, I think is a very high level skill that the top candidates would have been able to find. So. In terms of this question, so thanks for watching, and I hope to see you all in the walkthrough for question 1C.